Today you're going to review percentages, and we're going to start off by remembering how we convert between fractions, decimals, and percentages here in question A. What we want to do with this list, we have a mixture of fractions, decimals, and percentages, and I want to put this in order from least to greatest, but in order to be able to do that, I need them all to be in the same form. And the question here says to change everything into decimals. And so you'll notice that we've already got a couple of decimals in our list. We've got a percentage here, and a fraction here. And remember, with a percentage, in order to change that into a decimal, you're going to want to take the decimal point and move it back 2 places to the left. And when you have a fraction, remember, it's the numerator that's being divided by the denominator. So in this case, 4 divided by 5. So I'm going to have you go ahead and change each of those into decimals first, and then you're going to write them in order from least to greatest, the way that they've been typed up here. Okay, so I'm going to give you a moment to go ahead and do that. In the next section, we're going to look at the most basic type of percent questions, and in order to solve these types, we're going to use the percent equation, which says that part is equal to the percent, or the rate, times the whole. And when using this equation here, we have to remember that when we have a percentage in our problem, we have to change it into its decimal form in order to come up with the right answer. And so in question 1, we're told what is 65% of 400. And so I'm just going to write down my equation. Part equals the rate times the whole, and I have to be able to place these values correctly into the right places into the equation. They give us 65%, which is going to be our rate, and so I'm going to put that in decimal form, which is going to be 65 hundredths. And then I have of 400. I'm trying to find some percentage of 400. Of is attached to the whole. So when I says of 400, 400 must be the whole, and so I'm going to have to multiply 65 hundredths by 400 in order to figure out P, the part. In question 2, we're told 10% of a number is 40, and we're trying to figure out what that number is. And so again, we're going to use part equals rate times whole. And once again, we're given the rate here of 10%, which is going to be 10 hundredths, or just 1/10 if you wanted to write that in decimal form. And then we're told that 10% of some number is 40. 40 is only 10% of the value, so the 40, the is 40, must be the part. And we're looking for the value of W, the whole, in this example. And so we're going to have to do just one step here in order to figure out the value of the whole. We're going to have to divide each side by that 1/10, or the 10 hundredths, and that's going to give us a value of 400 for the whole. In question 3, it says 7 is what percent of 28? So in this case, we're trying to figure out what the percentage or the rate is. And so I'm going to go ahead and use R for my rate. And using what I learned up above, the word is attached to the part. 7 is, so 7 must be the part. And the word of is attached to the whole, of 28. So I'm going to have R times 28. And again, I'm going to have to divide each side by 28 in order to get R all by itself. And that's going to give me 25 hundredths for the value of R. But I was looking for the percentage, and so we have to convert 25 hundredths into a percentage, and that's going to end up being 25%. In example 4, we're trying to figure out the percent increase from test 1 to test 2. And so our formula, our equation is going to be a little bit different this time. If we're looking for a percent increase, well, then we're going to use change equals rate times the original. The change is always compared to the original test score. And once again, we're looking for the percentage, so we're going to use R for our rate. And the change is what we have to calculate. On test 1, we had an 85. On test 2, we had a 93. 93 minus 85 is going to end up with a change of 8. And so 8 goes in for the change. And then on the original, R times the original. Well, test 1 was the original, and that's going to end up being 85. And so we're going to have to divide each side by 85. And punch that into your calculator. You're going to have to write out all of those values, those decimals. 0 and 0.9411765 ends up being the value of R. But once again, we're looking for the percentage, so we move our decimal 2 places to the right. 9 and 4.11765% increase is what we would have in this example. Now we're going to look at some percent problems that are used with money, and two places where percents get used with money are when we're calculating a gratuity or a tip, as well as with tax. And we'll start with our gratuities first. Doug left $3 as a tip on a lunch bill of $14. What percent of the tip did Doug leave? And so we have our tip equation up here. The gratuity is equal to the percent times the original, which in this case is going to be the amount of the bill. And so if we write this down here, okay, we're going to have our gratuity equals the rate times the original bill. And we know that it was a $3 tip that was left for our gratuity, so I can go ahead and write in 3 for the gratuity. And we're trying to figure out the percentage, so we're going to use R for our rate. And the original bill was for $14. And so we should go ahead here and divide each side by 14. And that's going to give us a value, 3 divided by 14. Again, write out all those decimals. 0.2142857 equals R. But once again, we're looking for the percentage, and so we're going to turn this into a percentage. This is 21 and 4.28571%. So Doug left a little more than 21% of the bill as his tip. With our tax example, the equation is tax equals the rate times the original. In this case, the original we call the subtotal. The amount before tax is called the subtotal. And so we see here that Sarah has $124 of clothing to buy at Old Navy, and it asks what the total cost is with tax if the tax rate is 7.5%. Remember that 7.5% is the same as 7 5/10%. Which is going to be useful when we are converting a little bit later on. So we'll write down our formula. Tax equals our rate times the subtotal. And they've told us that the tax rate was 7.5%, so I'm going to change this into decimal form, move the decimal 2 times to the left, 0 and 75 thousandths. The subtotal, the price before tax, was the $124. And T, the tax, is what we are calculating. And so all I have to do is multiply these values together. And when I punch that into my calculator, I end up with a value of 9 30 hundredths. $9.30 is the amount of tax. What you need to do now in order to find the total is you take the subtotal of $124 and you add on the tax to figure out the total you would pay at the register. And that's going to leave us with a total of $133.30. A couple more percent word problems now. In question 8, we're told that 48 female students participated in a science fair. This represents 60% of the total students that participated. How many total students participated in the science fair? And so for this, I'm going to use the original percent equation, part equals rate times whole. And I'm going to read through here and see what I've got. I know that there were 48 female students at the science fair. Well, that's only part of the people that were at the science fair. So I'm going to have 48 as my part. And they tell us that these 48 female students represent 60% of the total. So my rate is 60%, which is going to be equal to 6/10. And we're looking for the total number of students that participated, which is going to be the whole. And so we're looking in this case for W. I'm going to have to divide each side by the 6/10 to get W all by itself. And when I do 48 divided by 6/10, I end up with a value of 80. The W, the whole, is equal to 80, which means that 80 students participated in the science fair. 80 students participated in the science fair. Another example of a percent problem that involves money is when you're trying to calculate the amount of a discount. And for that, we would use the equation discount equals the percent or the rate times the original price. And in number 10, we're told that a sweater is discounted by 20%, and the original price of the sweater was $35. And in part A, we want to know, well, what is the discounted price or the sale price of the sweater? And so I'm going to go ahead and use my equation. And again, that's discount equals the rate times the original price. And reading through here, I know the rate of discount was 20%, which is going to be 2/10. And they tell us the original price of the sweater was the $35, and so we have to calculate the amount of discount. So for this, to get the value, all I have to do is multiply the 2/10 by the 35, and when I do that, I get an answer of 7, meaning $7 was the amount of discount. This is not the sale price. This is how much money that you save. In order to get the sale price or the discounted price, you have to take the original and subtract off the amount of discount. And in this case, that's going to give us a price of $28. The sale price or the discount price is $28. In part B, you're going to calculate how much the total would be if there was an 8% sales tax. In our last example, we're going to try to calculate the percentage of change, just like we had done with the test examples earlier on. Again, the equation says that the amount of change is equal to the percent of change multiplied by the original amount. And so in this case, we're told that the sale price of a couch is $400 and the original price was $500, and we want to know what the percent discount was on that couch. And so I'm going to use my equation. Change is equal to the rate times the original amount. And what I'm going to have to do here is see how much the change was going to be. Well, the original price was $500. Now the sale price is $400. Well, we know that 500 minus 400 is 100, and that's how much the price changed on the couch. Again, the original price was the $500, and we're trying to find the percent discount. So R times 500 in this case. And so to get R all by itself in this example, we'll have to divide each side by the $500. And 100 divided by 500 is going to equal 2/10, which is the value of R. But we wanted the percentage, so again, we change this into a percent, and we get 20% here. And so we can say that the price of the couch was discounted 20%.